Okay, so this will serve as the prep video for section 2.1, Introduction to Limits. So the first thing we need to do is define what a limit is. So a limit is the expected y value. So two things importantly here. A limit is, the answer to a limit is a y value. That's an important thing to know. The expected y value for a given x value. So we put an x in, and there's some expected y that comes out. Another way to think of it is the value that y approaches again, so we're using kind of interesting language that y approaches as x approaches a particular value. So notice, nowhere in here does it say the actual value of y or the exact value of y. And so we'll get to that when we look at some examples here. So let's go ahead and write out what the notation is. Let me write it out over here. We write the limit as x approaches c. So the limit as x approaches a given value, we just call that c, of whatever the function is equal to L. And L, again, is a y value. So we know what's happening with x, and we're figuring out what's happening with y. So again, we would read that the limit as x approaches c of f of x equals whatever the limit equals. Okay, so, oh, and one other thing we need to write out over here is, you may have seen this abbreviation before, DNE. This stands for does not exist. So one thing for a value not to exist, it's a different thing entirely for a limit not to exist. So we need to really focus on the difference. So let me give you some graphs. All right, so let's start with this one. Y equals f of x equals x squared. Parabola, we know exactly what that looks like. And in this class, a sketch like that, until we get to chapter 4, a sketch like that is plenty good enough. Make sure it goes through 0, and that's great. Okay, so we're interested in the limit as x approaches 2 of f of x. So what is this, what's the y value doing when x is getting close to 2? So let's say here's 2, and if I want to, I can make this a little bit wider. I can kind of draw a dotted line. It's not an asymptote, it's just kind of a line for me to be able to know where I'm aiming for. So what I want to know is, what is y doing when we get close to x equals 2? Well, that point right there, if I put in x equals 2, I get y equals 4. I know exactly what the function is doing. As we get closer and closer to 2, coming in towards this dotted line, the y value is getting closer and closer to 4. So that's the limit. And in fact, if I were to write f of 2, it would be 2 squared, 4. Okay, so that makes sense. That's very easy. You would naturally expect we're not going to stay here. So let's look at a slightly different example. This is true except not when x is equal to 2. Okay, I'm going to leave this up here because we're going to ask the same question about the same function about x equals 2. So if you want to take a minute and write that down, that's fine. So let's graph this. Again, it's a parabola, but at x equals 2, what do we know? The value doesn't exist. Remember, we call that a hole in the graph? So there's no value there. So the value, f of 2, this does not exist. It is not defined. So the question is the limit still defined? So let's think about that. Let's kind of draw our dotted line again. We want to know, as we're getting close to x equals 2, is the y value getting close to anything? Well, if I start cruising down here, or coming up this way, approaching x equals 2, approaching this dotted line, what's the y value doing? It's getting closer and closer to that point right there. The limit does exist. I know exactly what y is doing. It's headed towards 4. It will never have a point there. That doesn't matter. Okay, so that's a weird thing about limits. Limits are all about the approach, the expected value. The function definition is about the exact value. So again, in this case, as we approach x equals 2, the actual value does not exist, but the limit does. Okay, naturally, one more setup here. Now we're going to look at a piecewise function. So that same parabola with that same hole at 2, but now at 2, we're going to define it. We're going to give it something. Okay, so let's graph this again. Same parabola. Parabolas are getting a little more V-shaped. We have this point at 2 that does not exist on the graph. And instead, so this point was supposed to be 4 if it had been on the graph, but it's not. In fact, it's right here. So we've got this nice curve, and then in this one place where there's a hole, there's nothing there, we actually put the point somewhere else. So now the question is, what is the limit and what is the actual value? Okay, the actual value, if I plug in x equals 2, I know I don't use this definition because x equals 2 is not part of this range, so I'm going to use this right here. So when x is 2, the function is 2. It is defined. What is the limit doing? Again, let's draw our dotted line in. As I'm cruising down and up the curve, remember it's about the approach of the y value. I don't really care what happens when I get there. I just want to know what I'm aiming for. So as I'm cruising down, this is headed exactly for that point right there that does not exist on that curve. That's where it's going. So because that's where it's approaching, that is the answer to the limit. So here, the limit and the actual value are not the same. And that's okay because we're talking about two different things. The function is the exact value. The limit is the approaching value or the expected value. Not the same thing. So they don't have to have the same answer. But when they do, it tells us something important. So let's sum up a few things here. The limit is about the approach or the expected value. Actual value do not need to be the same. So far, this has been, as we approach, we've been kind of heading to the same place from either side. Should we expect that that will always be the case? Can you think of a graph in your mind where coming from two different directions to a particular point on the graph, you don't have the same behavior? And I guess my thought would be anything with an asymptote. If I'm looking at this point here, coming from this side, I'm doing one thing. And going from this side, I'm doing something entirely different. So now that says we need to define some more limits. So we need to define one-sided limits. So we will have a left-sided limit. And naturally, a right-sided limit. Okay, so the left-sided limit is what happens as you approach the point of interest, the x point of interest, from the negative side, the left side. And so we'll write it this way: the limit as x approaches whatever value you're interested in from the negative side. From the negative side. Right-sided limit will be x approaching c. You might guess the notation from the positive side, the right-hand side. So we can talk about right and left-sided limits, so let's do that. I'm going to give you a couple of graphs. Let's start with this one. Okay. This graph actually does come from somewhere. This is actually the graph for the slope of an absolute value graph. And so we'll look at that later in the semester. Okay, so let's look. The limit as x approaches 0. So this right here, this is still what we're interested in, but from the left side only. All right, so let's look at that. So that means I'm only interested coming from this direction. So as I'm coming from this direction, I'm following the curve. The y value appears, I didn't write that in. The y value appears to stay at -1. That's true. So this from the left-hand side is -1. We can do the same from the right-hand side. So approaching from this dotted line, our x value of interest, heading towards it, from the right-hand side, we see we stay at 1. So in this case, the left-sided limit and the right-sided limit do not agree. And sometimes you'll see me write it this way, just left limit and right limit. And in a case like this, I might say left limit does not equal right limit, just some shorthand. Okay. Okay, so now we need to define two-sided limits. So we've got one-sided limits here, left and right. These are one-sided. So now let's come back and define a two-sided limit. The two-sided limit exists if the right limit equals the left limit. And that kind of makes sense, right? I mean, if from the two sides you're going to the same place, then that makes sense. So this is where the left limit equals the right limit. Oops. Try that again. Okay, so the two-sided limit exists. Let me finish it all out. Exists if the left limit equals the right limit. So let's come back to this one. Does this two-sided limit? So let's look at the distinction in notation. Left-sided and right-sided have these negative and positive signs. If you don't see it, then you have to assume it's a two-sided limit. So for this function, does the left side equal the right side? Does the left limit equal the right limit? The answer here is no, so we would say that this one does not exist. Okay? So just to sum up, the limit as x approaches c, any particular value of interest of a function, is its limit. It's about the approach, the expected value, not the exact value. Does not exist, D and E. You have a left limit, a right-sided limit, and then a two-sided limit that exists if these two are equal to each other. Okay, so let's look at a graph. And this is actually a graph out of the book. So if you would like to look at the book, you get a little bit clearer picture, that's okay. This is page 122, figure 3. And it looks something like this. Here. Sorry, I keep dashing back and forth. So here, here, and then -2, 4. Sorry, this is taking me so long. 2. Have a book in front of me, that would help. Okay, I think that's right. Okay, so we can ask some interesting questions here, several of them. So let's look at some limits. Let's look at the limit as x approaches, let's start with as x approaches 0. So that means if you want to, again, draw on your dotted line. As x approaches 0, I'm traveling on the graph. As x approaches 0, what's happening? I didn't pick a very good one, because I don't happen to know that value off the graph. So let me pick another one. It's a little bit easier. Let's try this one. As x This one's here. All right, so let's try as x approaches 2. So as x approaches 2, get some different colors going. As x approaches 2, I want to approach that line. So I'm on the graph, approaching the x value of interest. And what do I see? I see that it's going exactly, well, if we graph on graph, to 2. 3. Oh my goodness. No, 2. I was right the first time. Okay, sorry, I'm having trouble seeing my graph. Okay, so that's one. So let me back up. So we've got this graph. If we're looking as x approaches 2, there's no plus or minus, so we're looking at a two-sided limit. So the two-sided limit, there's a point right there. Everything is very normal, and that point should correspond to y equals 2. All right, so let's look at another one. Let's look at x approaching 3. This is not a one-sided limit. It's a two-sided limit. So now I'm interested in this place. Okay, so now I'm going to approach here. So again, the graph is doing something very nice, right? As I'm going here, I'm approaching, it's approaching 3. It's all looking very fine. So this approaches 3. Its actual value is not there. That doesn't matter. Remember, limits are not about the actual value. So in this case, the two-sided limit exists, but it does not match the actual value. That's okay. All right, so let's look at another one. Let's look at what happens when let's look at this one. The limit as x approaches -2 from the minus side. -2 from the negative side, left side limit. So I'm interested here. I'm only interested in the left limit, so I'm only going here. So as I follow the curve headed towards this x value of interest, I get to y equals 5. If you looked at the right-sided limit, it'd be the same thing. So because the right and the left agree, the two-sided limit would also exist. All right, let's look at this one. Let's look at the limit as x approaches -4. And let's look from the negative side and from the positive side. Okay, so the limit as x approaches -4 from the negative side, and the limit as x approaches -4 from the positive side. I should warn you that with limits we write down a lot. That's okay. You have to write it all out. You really do. Okay, so again, let's look here. We're looking as x approaches 4, so we want to go in this direction and in this direction. So from the left-hand side, as x is approaching 4, -4, this value is supposed to coincide with y equals 2. That's where it's supposed to line up. So as I'm approaching this direction, that right there is 2. When I'm coming from the right-hand side, however, I'm coming down, and this lines up with y equals 3. So question, does the two-sided limit exist? From the left I have one value, from the right I have another value, so that means that the limit, the two-sided limit, as x approaches -4, does not exist. Okay, so the take-home point for this whole prep video is the idea that limits are about approaching and expected values, not actual values, and that we have left and right-sided limits. If they agree, then the two-sided limit exists. So I guess that's it.